All right, so let's work this problem out. So we're given that you have this type of carbon steel, and they give us the density, they give us the thickness, and how wide it is, um, and they will also give us temperatures. And what they want us to find is the speed of the steel, okay, as it is going through this chamber. And they also give us the rate of heat transfer being removed from this steel strip, which is 100 kilowatts. So one of the things that I always like to do is I like to write the things that I'm given. If you still a little confused about some stuff, I tend to go with the units. The units will help you guide your entire problem. I know that this here is watts, kilowatts, okay? And I know that that refers to the rate of energy transfer, which is 100 kilowatts. Change in temperature is going to be 527. Uh, oh, I mean, it's going to be negative. But I'm just not, and it's going to be negative because we're losing energy, but I'm just going to keep it as positive. So 527 minus 127, and this is in degrees Celsius. So when I do the math, my change in temperature, it is just going to be, let me just double check. So it's going to be 527 minus 127, which is going to be 400 um, degrees Celsius. I can change this to 400 kelvins, and the reason for that is because of what we've gone over in class. We add the same amount of if we want to go from degrees Celsius to kelvins, so we add 273 to 527 and 273 to 127, and we subtract them, we still get the same value as 400, something that I'm not gonna go over. You know what, maybe I should, which means that this video will be just a bit longer, which is okay. So subtracting this gives me 400 degrees Celsius, okay? But if I want to go from degrees Celsius to kelvins, so from degrees Celsius to kelvins, what I need to do is I need to add 273.15 degrees, which is kelvins is equal to degrees Celsius, but plus 273.50. I'm just going to leave it as 273 for simplicity. So 527 plus 273, okay? What that gives me, it is 800 kelvins. Now if I do the same thing for 127, so 127 plus 273, when I add those two together, I should get 400 kelvins. Notice that I no longer have, excuse me, I no longer have degrees Celsius. Now I have kelvins. Well, if I do the change in temperature, in this case 800 kelvins minus 400 kelvins, then my change in temperature is going to be 400 kelvins. Okay, reason why I said I can just use this one. I do this knowing the what's going on the back end, which is this here, and I just don't change degrees Celsius to kelvins because hey, it's gonna be on my benefit. No. Okay. Another thing that we have to do is find the area. So area is 2 millimeters, but I know that I need to have those in meters. Now millimeters, it's 1,000. So I need in order to change it to meters, I have to divide by 1000, which is going to give me 0.002 meters. Okay. Actually, let me change the variable here because that's not the area just yet. Now I'm gonna take care of the other one, which is 3 centimeters. 3 centimeters. I know centi, that's 100, so I gotta divide by 100, which is going to be 0.03 meters. Now I can take my area to be 0.002 meters times 0.03 meters. So when I multiply this, I should get 0.00006 meters square. Okay. What else am I given? I'm also given the density. So I'm given rate of energy transfer. I'm given the change in temperature. I'm given my dimensions from which I can find the area. I'm also given the density. Density turns out to be 7832. Is that right? 7832. Yep. Kilograms per meter cubed. Okay. And seems like that's everything that I'm given. Okay. Now, since I wanted to find the speed of a steel, I know that I'm gonna be using this formula. Q dot is equal to m dot c delta t. Why do I know that? Well, because the mass flow rate has speed in there. Remember, mass flow rate is equal to the density times the speed times the area. Reason why I decided to find the area, I'm given the density, and this is what I'm looking for. I'm looking for the speed. Okay. So I can essentially make a substitution into this formula right here. So if I was to do that, Q dot is equal to not only m dot, but I'm gonna place this entire thing, which is the density times the speed times the area times the specific heat times the change in temperature. Now if I want to make things a lot more simpler, I can isolate the speed by dividing everything. Let me just make some space for myself, because put in there. And I don't need this here. Okay. So I'm gonna divide both sides of the equation by the density times the area, specific heat, change in temperature. Okay. So what happens is that change in temperature cancels out, specific heat cancels out, area cancels out, density cancels out. And the only thing that I'm left with is the speed, which is what I'm looking for. Now I'm gonna rewrite this and I'm gonna say, hey, the speed, okay, is now equal to Q dot divided by density, area, specific heat, change in temperature. Out of which I have pretty much everything. I know what that is. I know what the change in temperature is. I know what the area is. I know what the density is. I just need to figure out the specific heat. Now, here's the tricky part. We tend to go and divide and add the temperatures and then divide them by 2. I know in class we are not doing that, but just just so you guys know, we tend to do that, and that is because if the change in temperature, if there's a change in temperature and it's not, eh, at a constant temperature range, I guess you can say, what we tend to do is that we tend to average out the temperature. So essentially the average temperature would just be 527 plus 127 divided by 2, which if you to do that, you get 327 degrees Celsius. Let's change that to kelvins. The reason for that is because if we go back to the table, temperatures are in kelvins. And I'll show you guys right now the table. So if we were to add 273, then the average temperature would just be 600 kelvins. So this is where I'm going to get my specific heat. So if I go to the table, again, specific heat at 600 kelvins. If I go down the table, I'm gonna find it. And the way that they have this set up is that they're given the thermal conductivity on the top and then the specific heat on the bottom. And we're looking for, they're looking for this type of material, okay? Which means that if I go here, I have this 2. So my specific heat is going to be 685. I think we used this one. Let me see. Specific heat. We used this one, which is, you know, for us, for the purpose of our class, that's fine. But if we want it to be more accurate, we would use this one. 685. Okay. 685. So which means that specific heat is equal to 685 joules divided by kilograms times kelvins. Now, having said all of this, all we have to do now is just plug everything in, and we should be able to solve this problem. I think I do have enough space, so let's just go with this. So then my speed is going to be 100 kilo. I know it's 1,000, so I'm just gonna put 1, 2, 3 watts. Okay. Divided by what's it called? The density, which we know it's this one, so it's 7,832. I think I'm gonna need more space actually. $32 kilograms times meters cubed. Area 0.12346 meters square. Specific heat is what we just found, which is 685 joules kilograms kelvins, and my change in temperature we said was 400 kelvins. Let's start canceling units. So kilograms cancel out. Okay. What else cancels out? Meters square cancels out with 2 of them, which I'm left with only one. Kelvins cancel out as well. All right. What else? I think that's it. So I'm left with the speed is equal to 100,000. I'm gonna change watts to joules per second divided by so when I multiply all of this out, when I multiply this times that times that. I think I get 728,000. Let me see. Let me just double check. No, it's 128,758.08, and this is still joules per meter. Okay. And then if I put this into the calculator, I'm gonna get about 0.77. Now here's the thing on how to deal with this type of units. I have joules per second divided by the joules per meter, and this is a great time for me to go over how to deal with fractions. Okay, so I have joules divided by second divided by joules per meter. Okay, this here, it's division, so I have a whole bunch of divisions going on in here, right? So I'm gonna rewrite it like this. Now I can't divide fractions, so what I'm gonna do is that I'm going to change the division to multiplication. If I do that, I need to do the reciprocal of this ones, and when that happens, my joules cancel out, and I'm left with meters per second. So my speed is actually 0.77 meters per second, and that's the answer. Okay, hope that helps.